In this video, we're going to talk about how to apply quadratic functions and inequalities to solving real-life problems. So remember, we talked about using Polya's problem-solving process whenever we see word problems. Remember, it's always important to first read the problem carefully and understand what it is that you're trying to solve. Make sure that you underline, circle, or highlight important information and define variables. Then we'll make a plan which will involve setting up equations or inequalities to represent what's being described in the problem. Then we'll work on solving the equations or inequalities. And remember, we finally want to reflect and make sure that our solutions make sense in the context of the problem. So when we read word problems, remember we need to be on the lookout for these important words and phrases that tell us we'll be setting up an inequality to solve the problem. So if you see any of these, you want to make sure and highlight them because we'll be translating those into inequality symbols. So let's use quadratic functions and inequalities to solve real-life problems. So first, read the problem carefully, define any variables, set up a quadratic equation or inequality to set up the problem, and then rearrange the equation or inequality into standard form so you can solve. Then you want to verify that your solutions are reasonable. So let's start off with this example. A diver jumps from a diving board that is 4 feet above the water. The function h of t equals negative 3t squared plus 4t plus 4 represents the height in feet of the diver above the water t seconds after the jump. After how many seconds will the diver reach the surface of the water? So what I like to do with these problems is I like to sketch myself a little bit of a diagram so that I can see what's going on. So he's on this diving board, okay? And so this diving board is a certain amount of feet above the water. So here's my water down here. So we know the distance from here to here is 4 feet, okay? And then we know that the function tells us his height after the jump, right? So he's gonna like jump up and then go down and then eventually hit the water. So let's use our function h of t equals negative 3t squared plus 4t plus 4. So the height of this function is telling us basically how high he is above the water, okay? So when he's at the water, like when he hits the surface, he's going to be at height equals 0, right? Because that's the way this function is set up. So this is negative 3t squared plus 4t plus 4 equals 0, and that's basically the equation that they want us to solve. So you can use any method that you want to solve this equation. I'm going to choose to do the quadratic formula. So I'm going to call this A, B, and C. So A is negative 3, B is 4, and C equals 4. So if I first calculate the discriminant will be B squared minus 4AC. So we have D equals B squared, which is 4 squared, minus 4 times A, which is negative 3, times C, which is 4. So we have D equals 4 squared, which is 16, minus 4 times negative 3 is negative 12. Negative 12 times 4 is negative 48. 16 minus negative 48 is going to become 16 plus 48, which is D equals 64. So 64 is positive, and 64 is also a perfect square. So I know I will have two real rational solutions. Okay. So let's go ahead now and plug into the quadratic formula. So I have t equals negative b, so negative 4, plus or minus the square root of d, which is 64. And that's all divided by 2 times a, which is 2 times negative 3. So we have t equals negative 4 plus or minus 8 over negative 6. So remember that negative 4 plus or minus 8 over negative 6, I can separate into two solutions. So I have t equals negative 4 plus 8 over negative 6, and I have t equals negative 4 minus 8 over negative 6. So negative 4 plus 8 is going to be 4, so I have 4 over negative 6, and we can reduce this fraction. 2 will evenly divide both, so I have 2 and negative 3, so that's going to equal negative 2 over 3. Now, if we simplify this fraction, negative 4 minus 8 is negative 12. Negative 12 over negative 6 is going to become positive 2. Well, let's think about our solutions in the context of this problem. It's asking us for how many seconds it'll take this diver to reach the surface of the water. Well, when we're talking about time, we can't include negative values, okay? So this negative 2/3 is not going to make sense. That's an extraneous solution because we can't talk about negative values when we're talking about time. But if we say that he hits the water after 2 seconds, that's a reasonable solution, right? So that's why we're only going to include that. So we're going to say t equals 2 seconds, and that is the only reasonable solution that we've found. So now let's try this example. So it says that a rocket is launched from a cliff that is 86 feet above the ground. The rocket has an initial upward velocity of 80 feet per second. The function h of t equals negative 16t squared plus 80t plus 86 represents the height of the rocket t seconds after it's launched. How many seconds after the launch is the rocket at least 150 feet above the ground? So let's think about this. We have our h of t, which is negative 16t squared plus 80t plus 86. We have this very important phrase right here, at least. Remember that at least means greater than or equal to, right? So we want our h of t to be greater than or equal to 150. So that gives us the quadratic inequality, negative 16t squared plus 80t plus 86 is greater than or equal to 150. So remember, I can solve this if it's in standard form, so I can do that by subtracting 150 from both sides. And when I subtract 150 from both sides, I get negative 16t squared plus 80t plus 86 minus 150, which is minus 64, and that's greater than or equal to 0. So if I solve the corresponding quadratic equation, negative 16t squared plus 80t minus 64 equals 0, I can start to figure out what is going on with this rocket. So I notice that all of these terms in this quadratic equation have a GCF. They all have a GCF of 16, and I'm going to go ahead and just factor out that negative 16 along with it. So I have negative 16, and I'm going to divide every single term in this equation by negative 16. So I have negative 16 t squared over negative 16 plus 80t over negative 16 minus 64 over negative 16, and that's equal to 0. So that gives me negative 16 times, this becomes now t squared minus 80 over negative 16, which is 5. So 5t, and then minus over negative becomes plus, so 64 over 16 is 4, and that's equal to 0. Well, when I have negative 16 times t squared minus 5t plus 4 equals 0, I can solve this by dividing both sides by negative 16. So when I divide both sides by negative 16, that's going to give me t squared minus 5t plus 4 is equal to 0. So now what I can do is I can solve this quadratic equation. And so you can solve using any method you want to. I actually like to factor. So I'm going to use factoring, especially since a equals 1. I think it's going to be pretty quick to factor this. So I'm going to look for factors of 4, and they need to have a sum of negative 5, okay? So 4 is positive, so I know my factors will have the same sign, but since 5 is negative, I know that all my factors are going to be negative. The factors of 4 are 1 and 4 and 2 and 2. So if I make all my factors negative, negative 1 plus negative 4 is going to be negative 5, which is the pair that I need. Negative 2 and negative 2 is negative 4, so obviously that's not going to work. So I'm going to turn this now into the equation t minus 1 times t minus 4 is equal to 0. So if I set each of these expressions equal to 0, I have t minus 1 equals 0 and t minus 4 equals 0. So now I'm going to go ahead here and add 1 to both sides, which gives me t equals 1. And then over here, when I add 4 to both sides, I'm going to get t equals 4. Okay, so I'm talking about time in this problem, and it is reasonable to have times of 1 second and 4 seconds, so I don't have to eliminate any of my solutions. So since I'm talking about an inequality, I'm going to go ahead now and draw a number line. So I'm going to include both of these values, 1 and 4, and then I'm going to figure out where I can find my solutions. So between negative infinity and 1, I'm going to pick 0, because since I'm talking about time, I obviously can't have any values that are less than 0. And then between 1 and 4, I'm going to pick 3. And above 4, I'm just going to pick 5. Okay? So let's now plug these into the original inequality. So when I plug in 0, I get negative 16 times 0 squared plus 80 times 0 plus 86 is greater than or equal to 150. So that tells me negative 16 times 0 plus 86 is greater than or equal to 150, which basically tells me that 86 is greater than or equal to 150, which is false. Now let's try plugging in 3. So we have negative 16 times 3 squared plus 80 times 3 plus 86 is greater than or equal to 150. So we have negative 16 times 9 plus 80 times 3, which is 240, plus 86, which is greater than or equal to 150. So when we add up all these terms, we have negative 144 plus 240 plus 86 is greater than or equal to 150. And that tells us that 182 is greater than or equal to 150, which is in fact true. So we will include this region in our number line. And then now let's test the value 5. So if I plug in t equals 5, I get negative 16 times 5 squared plus 80 times 5 plus 86 is greater than or equal to 150. Negative 16 times 25 plus 80 times 5, which is 400, plus 86 is greater than or equal to 150. Negative 16 times 25 is negative 400, so we have negative 400 plus 400 plus 86 is greater than or equal to 150, which tells us that 86 is greater than or equal to 150, which is false. Okay, so notice that we did have the inequality sign greater than or equal to, so I know my endpoints are included. So my solutions are only going to be going from 1 to 4, and those are reasonable values of time, right? We can have times that are between 1 and 4. So we're going to write the solution as time from 1 to 4, so square brackets at both endpoints, or we can write 1 is less than or equal to t less than or equal to 4. Okay, and so those are the solutions to this problem. Now you can go ahead and pause the video and try doing this example on your own. So this problem is interesting because it's talking about the area of a triangle. We know the formula for the area of a triangle is 1/2 base times height. So it says no more than 40 square inches, so we know the area has to be less than or equal to 40. So this allows us to set up the inequality 1/2 times x plus 2, which is an expression that represents the base, times x, which is what represents the height, is less than or equal to 40. Then we can set up the corresponding equation and we can work on solving. So I started off by multiplying both sides by 2 to get rid of that 1/2, and then I distributed the x to both terms in my expression. So that gave me x squared plus 2x equals 80, and then I subtracted 80 from both sides to get x squared plus 2x minus 80 equals 0. I chose to solve by factoring, and I got the two solutions, x equals 8 and x equals negative 10. So I know this does break my number line into regions, but there are some regions that I don't even need to test. So for example, I didn't test anything that's less than 0 because we have to remember, think about the context of our problem. We're talking about the height and the base of a triangle. So it does not make sense to include negative values of x, right? Because length can't be negative. So that's why I added in this 0 here, and then I chose not to test any values that were anything, negative. So what I did is between 0 and 8, I chose to test 2, which did make my inequality true. And then above 8, I chose to test 10, which made my inequality false. So that's why my solutions will be in the interval from 0 to 8 with both endpoints included. And I can rewrite that as 0 is less than or equal to x, which is less than or equal to 8. So remember that quadratic functions and inequalities can be used to represent real-life situations. By setting the function or inequality in standard form and solving, we can determine the solutions to the problem.